The National Electrical Code Section 300.3b states that conductors of different systems shall not occupy the same electrical box. Furthermore, Section 300.3c says that conductors of two or more different circuits shall not occupy the same electrical box unless the box is of sufficient size to accommodate the conductors of all circuits contained within it, and the conductors are protected from contact with each other by approved barriers. The question at hand involves splicing different branch circuits, which are considered different systems, into one large junction box. It also concerns splicing 120 volts and 240 volt circuits, which are also different circuits, in the same box. Based on the National Electrical Code requirements, it is not compliant to use one large junction box to splice different branch circuits on 120 volts or 240 volt circuits together without proper separation. To comply with the National Electrical Code, several alternative solutions can be considered. Firstly, install multiple junction boxes, using separate junction boxes for each branch circuit and voltage level. Secondly, consider using a large junction box with barriers. If a single junction box is desired, it must be large enough to accommodate all the conductors, and approved barriers must be used to physically separate the different circuits. It's crucial to ensure that these barriers meet the code requirements for preventing contact between conductors. Thirdly, explore the use of wireways or gutters. These can be used to route the different conductors separately, maintaining the required separation as specified by the code. The National Electrical Code stipulation against having different systems in one box is in place to ensure electrical safety and prevent potential hazards. Mixing different circuits and systems in the same box can increase the risk of electrical problems, such as short circuits and ground faults. Therefore, strict adherence to code requirements is important to maintain electrical safety and prevent potential issues. The wire fill of a junction box refers to the maximum number of conductors that are allowed to be installed in a box. The National Electrical Code provides guidelines and calculations to determine the proper box size based on the number and size of the conductors, as well as any devices such as splices or terminals located within the box. The purpose of these requirements is to prevent overcrowding, which can lead to overheating, insulation damage, and other safety hazards. When calculating wire fill, each conductor that passes through the box or terminates within it is counted. Different size conductors have different fill allowances, as specified in the National Electrical Code tables. In addition to conductors, allowances must also be made for devices such as switches, receptacles, and equipment grounding conductors. The volume of the junction box must be sufficient to accommodate all the conductors and devices without exceeding the maximum fill capacity. It is important to carefully calculate the wire fill for each junction box to ensure compliance with the National Electrical Code and maintain electrical safety. Overfilling a junction box can create a dangerous situation and may result in code violations. When dealing with electrical installations, there are various types of wiring methods that can be used, each with its own specific applications and requirements. Romex, which is also known as non-metallic sheath cable, is a common type of wiring used in residential buildings for branch circuits and feeders. It consists of two or more insulated conductors enclosed in a non-metallic sheath. Romex is suitable for dry locations and is typically used for wiring outlets, lights, and switches. Conduit, on the other hand, is a rigid or flexible metal or plastic tube that is used to protect and route electrical wiring. Conduit is often used in commercial and industrial buildings, as well as in areas where the wiring may be exposed to physical damage or moisture. There are different types of conduit, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit, each with its own specific properties and applications. Another type of wiring method is cable tray, which is a support system used to route and support insulated conductors, cables, and busbars. Cable trays are commonly used in industrial and commercial facilities to distribute power and control signals. They can be made of metal or non-metallic materials and are available in various sizes and configurations. In addition to these common wiring methods, there are also other specialized types of wiring, such as mineral insulated cable, which is used in high-temperature environments, and underground feeder cable, which is used for direct burial applications. The selection of the appropriate wiring method depends on several factors, including the type of building, the environmental conditions, the voltage and current requirements, and the applicable codes and standards. It is important to carefully consider these factors and consult with a qualified electrician to ensure that the wiring method chosen is suitable for the specific application. Different electrical systems have different voltage levels to suit various applications. In residential buildings, the most common voltage levels are 120 volts and 240 volts. The 120 volt system is typically used for lighting, small appliances, and general purpose outlets. The 240 volt system is used for larger appliances such as electric ranges, dryers, and air conditioners. In commercial and industrial buildings, there are often higher voltage levels such as 208 volts, 277 volts, and 480 volts. The 208 volt system is commonly used in three-phase power distribution systems, while the 277 volt system is used for lighting in large buildings. The 480 volt system is used for powering large motors and equipment. The choice of voltage level depends on the power requirements of the equipment being served, as well as the efficiency of the power distribution system. Higher voltage levels are generally more efficient for transmitting power over long distances, as they reduce the amount of current flowing through the conductors. However, higher voltage levels also require more robust insulation and safety measures. When working with different voltage levels, it is important to follow all applicable codes and standards to ensure electrical safety. This includes using the correct type of wiring and equipment, providing proper overcurrent protection, and implementing appropriate grounding and bonding techniques. It is also important to be aware of the potential hazards associated with different voltage levels and to take precautions to avoid electrical shock. Electrical safety is paramount when working with any electrical system. One of the most important safety measures is to always energize the circuit before working on it. This means turning off the power at the circuit breaker or fuse box and verifying that the circuit is indeed dead using a voltage tester. It is also important to use properly insulated tools and equipment to prevent accidental contact with live conductors. Another important safety measure is to wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Rubber gloves provide insulation against electrical shock, while safety glasses protect the eyes from flying debris or arc flash. It is also important to be aware of the potential hazards associated with arc flash, which is a dangerous electrical explosion that can occur when there is a fault in the electrical system. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash, it is important to wear appropriate arc-rated clothing and equipment. In addition to these safety measures, it is also important to follow all applicable codes and standards, such as the National Electrical Code, and to receive proper training on electrical safety procedures. Electrical work should only be performed by qualified and licensed electricians who have the knowledge and experience to do the job safely. The National Electrical Code, often referred to as the NEC, is a set of standards and guidelines for the safe installation of electrical wiring and equipment in the United States. The National Electrical Code is developed and published by the National Fire Protection Association, or NFPA, and is updated every 3 years to reflect changes in technology and industry best practices. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for the size and type of conductors, the installation of raceways and enclosures, and the selection and use of electrical devices. The National Electrical Code is not a law itself, but it is widely adopted by state and local jurisdictions as the basis for their electrical codes. Compliance with the National Electrical Code is essential to ensure the safety of electrical installations and to prevent electrical hazards such as fires and shocks. The National Electrical Code is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. It is important for electricians and other electrical professionals to be familiar with the National Electrical Code and to stay up to date with the latest revisions. The National Electrical Code also includes informative annexes that provide additional guidance and explanations of the code requirements. These annexes are not part of the enforceable code, but they can be helpful in understanding the intent and application of the code provisions. Grounding and bonding are two important concepts in electrical safety. Grounding is the process of connecting the electrical system to the earth, while bonding is the process of connecting all metal parts of the electrical system together. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source, which will cause the overcurrent protection device, such as a circuit breaker or fuse, to trip and de-energize the circuit. This helps to prevent electrical shock and fire hazards. Bonding is the process of connecting all metal parts of the electrical system together to create an electrically continuous path. This helps to equalize the voltage potential between different metal parts, which reduces the risk of electrical shock if someone comes into contact with two different metal parts at the same time. The National Electrical Code provides detailed requirements for grounding and bonding, including the size and type of grounding and bonding conductors, the methods of making connections, and the location of grounding electrodes. It is important to follow these requirements carefully to ensure the safety of the electrical system. Grounding and bonding are essential for protecting people and property from electrical hazards. Overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from excessive current flow, which can cause overheating, insulation damage, and fires. Circuit breakers are automatic switches that trip and open the circuit when the current exceeds a predetermined level. Fuses are devices that contain a fusible link that melts and opens the circuit when the current exceeds a predetermined level. The National Electrical Code provides detailed requirements for overcurrent protection, including the size and type of overcurrent protection devices, the location of overcurrent protection devices, and the coordination of overcurrent protection devices. It is important to select the appropriate overcurrent protection devices for each circuit to ensure that the electrical system is properly protected. Overcurrent protection is essential for preventing electrical fires and protecting equipment from damage. Electrical boxes, also known as junction boxes or outlet boxes, are enclosures used to house electrical connections and protect them from the environment. Electrical boxes are typically made of metal or plastic and are available in various sizes and shapes. The National Electrical Code provides detailed requirements for electrical boxes, including the type of box to be used in different locations, the size of the box, the number of conductors allowed in the box, and the methods of supporting the box. It is important to select the appropriate electrical box for each application to ensure that the electrical connections are properly protected and that the box is installed in accordance with the National Electrical Code requirements. Electrical boxes are essential for providing a safe and reliable electrical system. Wireways and cable trays are support systems used to route and support electrical conductors and cables. Wireways are enclosed channels used to protect and route conductors, while cable trays are open support systems used to support cables. Wireways and cable trays are commonly used in commercial and industrial buildings to distribute power and control signals. The National Electrical Code provides detailed requirements for wireways and cable trays, including the type of wireway or cable tray to be used in different locations, the size of the wireway or cable tray, the methods of supporting the wireway or cable tray, and the spacing between conductors and cables. It is important to select the appropriate wireway or cable tray for each application to ensure that the conductors and cables are properly supported and protected. Wireways and cable trays are essential for providing a safe and organized electrical system. In summary, when relocating house panels, it is important to adhere to the National Electrical Code requirements for splicing different circuits and voltage levels. It is not compliant to use one large junction box to splice different branch circuits and 120 volts or 240 volt circuits together without proper separation. Alternative solutions include installing multiple junction boxes, using a large junction box with barriers, or using wireways or gutters to route the different conductors separately. It is also important to follow all applicable codes and standards and to receive proper training on electrical safety procedures.